Good day, students. In this problem, I'm going to explain to you the solution of problem number 10 from exercise number 8 on the center of buoyancy. Problem 10 states that a barge 45 meters long has a uniform cross section throughout, which consists of a rectangle above a triangle. The rectangle is 8 meters broad and 4 meters high. The triangle is apex downwards, 8 meters broad and 3 meters deep. If the displacement of the barge is 1,620 metric tons, find the position of the center of buoyancy with reference to the keel and also with reference to the aft end if it is upright and on an even keel in fresh water. So with this data, here is the barge that has been constructed. Okay, it is a rectangle over a triangle. The length is 45 meters. The rectangle is 8 meters broad and 4 meters high. Height is 4 meters. The triangle is apex downwards, 8 meters broad and 3 meters deep. Now each of these shapes has its own center of buoyancy. The triangle has its center of buoyancy at location Bx, and the rectangle has its center of buoyancy at location By. The triangle is denoted by X and the rectangle is denoted by Y. We have to find the location of the center of buoyancy of the complete structure. Now this center of buoyancy of the complete structure will lie somewhere between Bx and By. The height of the triangle is given as 3 meters. Thus the center of buoyancy of the triangle will lie at its centroid, which is 2 meters from the apex or 1 meter from the base. The center of buoyancy of the rectangular section will lie at half the height between the waterline and the base. Thus, it is shown as to be lying at the point By. It is floating at a draft equal to d meters. This entire contraption is floating at a draft equal to d meters. The triangular section is submerged and a part of the rectangular section is also submerged. This part of the rectangular section that is submerged from its base is taken as height P until the waterline. P stands for Papa. This is the height from the waterline to the base of the rectangle. Thus, you will see that the draft is equal to P plus the 3 meters. Now we have to find the center of buoyancy with respect to the keel, the location that is this KB, as well as the location of the center of buoyancy from the aft end. So once again, I have drawn this in a three-dimensional format. The prism section, the bottom section is X and the rectangular section is Y. Everything else is shown exactly as I had mentioned earlier. Now we go to the next slide. In this slide, I have split the rectangle section and the triangle section into two separate parts and also turn the structure by 90 degrees to the right. You can turn it to the left in material, but I have taken it to the right. K is the keel, as was shown in this picture over here. K is the keel. Then we see Bx is the center of buoyancy of the triangular section, and since the entire triangular section is submerged, The center of gravity of the triangular section is also located at the same spot. The center of buoyancy, as was shown in this picture, was slightly outside of the triangle and into the rectangle space. So this is exactly what it is. The center of buoyancy, which we have to calculate actually, is slightly outside the triangle space and into the rectangle space. It could be lying anywhere. This is just what I have shown. It could be lying within the triangle space also. So please don't take it as it has to be within the rectangular space only. Thus I've shown this to be a little outside of the triangle space. Now I've shown the rectangle space also separately. The green line is your water line. Okay. The center of buoyancy of the entire shape, triangle as well as the rectangle, is shown here as capital B. The center of buoyancy of the rectangle space floating at this draft at this water line is located at half the distance from the base of the rectangle to the water line, and it is denoted by By. P is the distance between the base of the rectangle and the water line. Thus, let's start with the solution of the problem. Displacement of x, that is the triangle section, is equal to half base into height into the length and into the relative density of the liquid in which it is floating. As mentioned in the problem, she is floating in fresh water. The base is 8 meters, the height is 3 meters, the length is 45 meters. She is floating in fresh water, thus giving us a displacement only of the x section as 540 metric tons. Now we know from the problem, data given in the problem, that the displacement of the entire structure is 1620 tons. So we subtract 1620 tons, we subtract 540 metric tons from 1620 tons to get 1080 metric tons, which is the displacement of the rectangular section. Now this rectangular section is floating at a certain draft above the keel, or you can say from the baseline. Okay, so knowing this value of 1080, we can easily find the height of P. So displacement of y is equal to the volume of y into the relative density of the liquid. Now this volume is the underwater volume of the rectangular shape. Now the underwater volume of the rectangular shape is equal to length into breadth into P. This part is underwater, multiplied by the relative density of the liquid in which it is floating. Thus, we substitute the values. Displacement of y is equal to 1080, length is 45 meters, displacement is 1080, length is 45 meters, the breadth is 8 meters, T we don't know, and the relative density of the liquid in which it is floating is fresh water, thus the relative density is 1. With P being the only unknown in this equation, we get P is equal to 3 meters. That is, this height from the base of the rectangle is equal to 3 meters. In effect, now if we go back and see the previous slide, P being 3 meters, the draft of this complete shape is 3 meters plus 3 meters is equal to 6 meters. So she is in effect floating at a draft of 6 meters. Now, kg of x, since this the triangle is completely submerged, its center of gravity and its center of buoyancy are at the same location. Thus, kg of x and kb of x are located at two-thirds the height of the ship, which is 3 into 2 by 3, that is equal to 2 meters. That is kbx is equal to kgx, and that is equal to 2 meters. Now kb of y, we have to find the location of kb of the y. We know that P is 3 meters and the center of buoyancy of a box shaped vessel is located at half the draft. Thus, this point, this distance is half of 3, that is 1.5, and when taken from the keel, it is 1.5 plus 3, and that is equal to 4.5 meters. Thus, the kb of y is equal to 3 plus half p, that is 3 by 2 is equal to 4.5 meters. Now we have to take once again the moments about the keel to find the height of the center of buoyancy above the keel. Displacement multiplied by the kb of the vessel is equal to displacement multiplied by kbx, where x was the triangle shape, and displacement of y multiplied by kb of y, where y is the rectangular shape. Thus we have this equation, displacement being 1620 into the kb of the ship, and kb of x and displacement of x is 540 times 2, and displacement of y and kb of y is 1080 times 4.5. This has already been explained in the previous slide. Thus we see that the kb of the ship is equal to 1080 plus 4860 divided by 1620, thus giving the kb, that is the height of the center of buoyancy above the keel, to be 3.667 meters. Now, in the second part of this problem, we have to find the distance of the center of buoyancy from the aft end. Here we have to note what was given to us in the problem. She has a uniform transverse cross section throughout. That means from aft to forward, she has a uniform cross section throughout. Thus, if you were to cut this shape vertically at any point along this length of 45 meters, you would see exactly this shape and no other shape. So, with that argument, we can say that since the barge has a uniform transverse cross section and is on an even keel and is upright, thus AB, that is the distance of the center of buoyancy from the aft perpendicular, is equal to half length, and the length is 45 meters, thus AB is located at 22.5 meters. With this, I end this lecture on explanation of problem number 10 from exercise 8. If you have liked this lecture, please give me a thumbs up, please share this video as well as subscribe to my channel. Goodbye, good day, thank you.